calculations of Kc. That is how equilibrium constant is calculated. So here we have given an example. We are told 1.87 moles of air are placed in a 1 liter container at 700 K. 43.3% of air decomposed when the reaction reached equilibrium. So this is the equation we are given. A decomposes to form B and C. Then we're told calculate the value of Kc at 700 K, that is the same temperature. So the first thing we'll do, let us draw the ice table. We first draw ice table, that is initial, change, and equilibrium. So here we have A, B, and C. So the coefficient of A is 2, and the coefficient of B is 3, and C is 1. So we are told 1.87 of A, 1.87 mole of A are placed in 1 liter container at 700 K. So 43.3% of A decomposed when the reaction reached equilibrium. So this means 43.3% of 1.87 of A has decomposed. So to get now that will be 43.3% times 1.87. So that will be equal to, that is equal to 43.3%, that is 0.433 times 1.87, that is 0.89, 0.809 moles. So that is A. So, and the initial concentration of A is 1.87. So before we write that, let us fill the changes here. So this is a product, so we'll have negative X. And this 2 will have positive X, positive X. So A has a coefficient of 2, then we'll have negative 2X. And B, the coefficient is 3, so we'll have positive 3X. And the coefficient here is 1, so we'll have only plus X. So this is a mole of A that has decomposed, and this mole is equal to 2X, because the change of A is 2X, and the change of A we are given 0.089. That is the 43% of 1.7 A. So that means 2X, the change is equal to the number of moles of A, that is 0.809. So to get X, let us divide 2 and then 2. So we'll have X is equal to 0.809 divided 2 is equal to 0.4045. That is round off to be 5. So 0.405 moles is equal to X. So let us now replace, let's substitute where we have x with 0.0445. So multiply 2 times that will be 2 times 0.045 will be 0.0 0.809. X times 3 will be times 3, it will be 1.2 1, and x alone will be 0.405. So to calculate the equilibrium concentration is now easy. We'll only use the given values. So here we have got 1.87, so minus this value, which is 0.809. So subtract 1.87 minus 0.809. That is 1.061. That is the concentration of A, and B, the initial concentration of B is 0, and the initial concentration of C is 0. So subtract, add 0 plus 1.21, that will be 1.21. And 0 plus 0.405 will be 0.405. So since we have now got the concentration, the equilibrium concentration of A, B, and C, we can calculate Kc. Kc is equal to the equilibrium concentration of the product, all of the equilibrium concentration of the reactant. So product, we have got B and C. So the equilibrium concentration of B is 1.21. 1.21 raised to the coefficient, which is 3, multiplied by 0.045, which is the equilibrium concentration of C, 0.405. The coefficient is 1, so we don't need to write 1. And then the coefficient of the reactant, which is A, is 1.061. So all over 1.061 raised to 2, since the coefficient is 2. So let's calculate that. 1.21 cube is equal to 1.772 times 0.405 all over the concentration of this, 1.061 square, 1.061 square is equals to 1.125. That's less round off, so we'll have 6 there. So let's multiply 1.772 times 0.405 is equal to, let's just divide, is equal to 0.72 divide 1.126. So that is equal to, so our Kc is equal to 0.637 so 6.37. So that is